Welcome friends, welcome to Trichy Madhu Education. This is our second video. In the first video we see 10th standard science subject, important points in the first lesson, that is force and motion. Now we are going to see the continuation. We saw the action of forces in the first video. This is our second video. Now the resultant force, when several forces act simultaneously on the same day, then the combined effect of the multiple forces can be represented by a single force, which is termed as resultant force. Resultant force, when several forces act simultaneously on the same day, then the combined effect of the multiple forces can be represented by a single force, which is termed as resultant force. It is equal to the vector sum of all the forces, adding the magnitude of the forces with their direction. Vector sum of all the forces. When several forces act simultaneously on the same body, then the combined effect of the multiple forces can be represented by a single force, which is termed as resultant force. It is equal to the vector sum, that is, the adding the magnitude of the forces with their direction of all the forces. It's a resultant force. If the resultant force of all forces acting on the body is equal to 0, then the body will be in equilibrium. Such forces are called balance forces. What is balance forces? If the resultant force of all the forces acting on the body is equal to 0, then the body will be in equilibrium. Such forces are called balanced forces. If the resultant force is not equal to 0, then it causes the motion of the body due to unbalanced forces. If the resultant force is not equal to 0, then it causes the motion of the body due to unbalanced forces. Example, drawing water from a well, force applied with a crowbar, forces on weight balance, etc. A system can be brought to equilibrium by applying another force which is equal to the resultant force in magnitude but opposite in direction. Such force is called equilibrant. What is equilibrant? A system can be brought to equilibrium by applying another force which is equal to the resultant force in magnitude but opposite in direction. Such force is called as equilibrant. Rotating effect of the force. Have you observed the position of handle in a door? It is always placed at the edge of the door and not at some other place. Why? Have you tried to push the door by placing your hand closer to the hinges or the fixed edge? What do you observe? The door can be easily opened or closed when you apply the force at a point far away from the fixed edge. In this case, the effect of the force you apply is to turn the door about the fixed edge. The turning effect of the applied force is more when the distance between the fixed edge and the point of application of the force is more. The axis of the fixed edge about which the door is rotated is called the axis of rotation. The axis of fixed edge about which the door is rotated is called as axis of rotation. Fix one end of the rod to the floor or wall and apply a force at the other end tangentially. The rod will be turned about the fixed point is called the point of rotation. We are going to see moment of the force. What is moment of the force? The rotating or turning effect of a force about the fixed point or a fixed axis is called moment of the force. About that point or torque. The rotating or turning effect of the force about the fixed point or fixed axis is called moment of the force about that point or torque T. It is measured by the product of force F, capital F, and perpendicular distance d, small d, between the fixed point or a fixed axis and the line of action of the force. Torque T is equal to F into d. Torque is a vector quantity. It is acting along the direction perpendicular to the plane containing the line of action of force and the distance. Its SI unit is capital N M, Newton meter. The moment of force T is equal to F into d. It's a SI unit moment of force, or SI unit of moment of force is capital N small m, N into M. Couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. What is a couple? Two equal and unlike parallel forces applied simultaneously at two distant points constitute a couple. The line of action of the two forces does not coincide. It does not produce any translatory motion since the resultant is zero, but a couple results in causes the rotation of the body. Rotating effect of a couple is known as moment of a couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. The line of action of the two forces does not coincide. It does not produce any translatory motion since the resultant is zero, but a couple results in it causes the rotation of the body. Rotating effect of the couple is known as moment of a couple. What is moment of a couple? A rotating effect of the couple is called moment of the couple. If example, turning a tap, winding or unwinding a screw, spinning of a top. These are all the examples of couple. Moment of the couple. Moment of a couple is measured by the product of any one of the forces and the perpendicular distance between the line of action of two forces. Moment of the couple is measured. How moment of the couple is measured? Moment of the couple is measured by a product of any one of the forces and the perpendicular distance between the line of action of two forces. The turning effect of a couple is measured by the magnitude of its moment. The turning effect of the couple is measured by magnitude of its moment. Moment of a couple is equal to force into perpendicular distance between the line of action of forces. That is capital M is equal to capital F into S. Capital S. The unit of moment of a couple is Newton meter, that is a Nm in SI system, and dyne centimeter in CGS system. So moment of the couple, moment of a couple Newton per meter in SI system. It is dyne in CGS system. By convention, the direction of the moment of the force or a couple is taken as positive if the body is rotated in the anti-clockwise direction. When the body is rotated in the anti-clockwise rotation, the direction of the moment of force or a couple is taken as positive. When it is anti-clockwise direction, it is positive. When it is clockwise direction, it is negative. Application of torque. Torque is applied in the following seesaw, gears, steering wheel. These are the places where torque is applied. Gears, seesaw, steering wheel. Principle of moments. Principle of moments. And then what is the principle of moments? Moments in clockwise direction is equal to moment in anti-clockwise direction. That is F1 into D1 is equal to F2 into D2. Newton's second law of motion. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. According to this law, Newton's second law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. So the Newton's second law of motion, this law helps us to measure the amount of force. So it is also called as law of force. Newton's second law is also called as law of force. So Newton's second law of motion, F is equal to m into a, that is force is equal to mass into acceleration. That is force is equal to mass into acceleration. That is the Newton's second law of motion. Unit of force. What is unit of force? Yes, in the unit of force in SI unit is Newton. CGS system it is dyne. Units of force. SI unit of force is Newton, capital N. CGS system it is dyne. Definition of 1 Newton, capital N, is equal to the amount of force required for a body of mass 1 kg produces an acceleration of 1 meter per second squared. That is 1 N is equal to 1 kgm per second squared. That is kgm s power minus 2. That is 1 Newton is equal to 1 kilogram meter per second squared. Definition of 1 dyne is equal to what is definition of 1 dyne? The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter per second squared. That is 1 dyne is equal to 1 gram centimeter per second squared. Also 1 Newton is equal to 10 power 5 dyne. 1 Newton is equal to 10 power 5 dyne. That is the relationship between Newton and dyne. 1 Newton is equal to 10 power 5 by 10 power 5 dyne. So we saw unit of force, definition of 1 Newton and definition of 1 dyne. Unit force, the amount of force required to produce an acceleration of 1 meter per second square in a body of mass 1 kg is called unit of force. What is the unit of force? The amount of force required to produce an acceleration of 1 meter per second square in a body of mass 1 kg is called unit of force. Gravitational unit of force. In the SI system of units, gravitational unit of force is kilogram force represented by kgf. In the CGS system, its unit is gram force represented by gf. Gravitational force 1 kgf is equal to 1 kg into 9.8 meter per second square, that is 9.8 n. 1 gf is equal to 1 g into 980 centimeter per second square, that is equal to 980 dyne. So gravitational unit of force 1 kgf is equal to 1 kg into 9.8 meter per second square, that is 9.8 n. 1 gf is equal to 1 g into 980 centimeter per second square, that is equal to 980 dyne. So impulse, what is impulse? A large force acting for a very short interval of time is called as impulsive force. A large force acting for a very short interval of time is called as impulsive force. When the force F acts on the body for a period of time t, then the product of the force and its time is known as impulse, represented by J. Impulse J is equal to capital F into small t. By Newton's second law, there is a derivation. J is equal to P. Impulse is also equal to the magnitude of change in momentum. Its unit is kilogram meter per second or ns. Change in momentum can be achieved in two ways. How can we achieve a change in momentum? There is two ways. There is two ways: a large force acting for a short period of time and a smaller force acting in a long period of time. Example for this impulse: automobiles are fitted with the springs and shock absorbers to reduce jerks while moving on uneven roads. In cricket, a fielder pulls back his hands while catching the ball. He experiences smaller force for a longer interval of time to catch the ball, resulting in a lesser impulse on his hands. Newton's third law of motion. Newton's third law states that for every action there is an equal and opposite reaction. They always act on two different bodies. Newton's third law of motion states that for every action there is an equal and opposite reaction. They always act on two different bodies. If a body A applies a force F of A on the body B, then the body B reacts with a force F of B on the body A, which is equal to F of A in magnitude but opposite in direction. So the Newton's third law, F of B is equal to minus F of A. F of B is equal to minus F of A. That is the Newton's third law of motion. For every action there is an equal and opposite reaction. They always act on two different bodies. For example, for third law of motion, when birds fly, they push the air downwards with their wings and the air pushes the bird upwards. So the birds push the air downwards, that is action. Air pushes the bird upward, that is reaction. When a person swims, he pushes the water using the hands backward, action. And the water pushes the swimmer in the forward direction, that is reaction. When you fire a bullet, the gun recoils backward and the bullet is moving forward, action, that is action. And the gun equalizes this forward action by moving backward, reaction. Principles of conservation of linear momentum. There is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Let us prove the law of conservation of linear momentum with the following illustration. There is a derivation: conservation of linear momentum. What is derivation? m1 v1 plus m1 v2 is equal to m1 u1 plus m2 v2, m2 u2. m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. The above equation confirms in the absence of an external force, the algebraic sum of moments after collision is now numerically equal to the algebraic sum of the momentum before collision. Law of conservation of linear momentum is proved. So rocket propulsion of rocket is based on law of conservation of linear momentum as well as the Newton's third law of motion. Rockets filled with fuel, either liquid or solid, in the propellant tank. When the rocket is fired, the fuel is burnt and the hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber, which makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burned out. Since there is no net external force acting on it, the linear momentum of the system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increase in velocity of the rocket. At one stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the Earth. This velocity is called escape velocity. At one stage, the rocket reaches the velocity which is sufficient to just escape from the gravitational pull of the Earth. This velocity is called escape velocity. What is escape velocity? The rocket is reached the velocity which is sufficient to just escape from the gravitational pull of the Earth. This velocity is called escape velocity. Friends, we have seen lesson number 1, the continuation of video number 1, and by this we close the video number 2. Continue. Please listen our lessons again and again. Definitely it will be useful to you. Thank you, friends. Subscribe to Tamil Madhu channel.